So today's lesson will be on quantum theory. Some of the topics we're going to be covering include the photoelectric effect, superposition, the double slit experiment, and the wave equation. What is quantum theory? Quantum theory is a theoretical basis of modern physics explaining the nature and behavior of matter and energy on the atomic and subatomic level. This is often referred to as quantum mechanics or quantum physics. An important concept in quantum physics is the photoelectric effect. This is a phenomena where light shown on a metal releases electrons by overcoming something called the work function. This is important in determining light as a particle and not a wave, because when you increase the amplitude of the wave, it does not increase the kinetic energy. Instead, increasing the intensity of a particle can increase the kinetic energy. This went against traditional thinking and is an important revolution in understanding that light can behave as both a wave and a particle. So one other important experiment was a double slit experiment first done to prove that light behaves in a wave-like pattern. What happened was light was shown through two slits onto a screen, with the outcome not being two bright lines, which is what classical thinking would give you. However, as shown in the diagram here, you can see that it does not act like that. It simply acts in a manner that is more wave-like. You have constructive and deconstructive interference. So instead of having two bright lines, you have many bright lines and also many dark spots where you would have different forms of interference. Now, what if we did this with particles instead of waves? Let's assume that light is a wave. Sure, let's try electrons. We know they're particles. So if we shoot them one at a time through the slits, they can't possibly interfere. This was done, and what happened was you got the exact same interference patterns. So nothing had changed. Now, this puzzled experimenters because they didn't exactly understand why this was occurring. If there was no possible interference with particles, how could there be constructive and deconstructive interference? This didn't make any sense. So what they had done is that they tried putting an observer at the slit to observe the particles going through. Now, before the observation, as shown in this photo, there was waves. So there was constructive and deconstructive interference causing multiple fringes and dark spots. Now, after the observer, it acted as a particle. So you actually had two bright lines instead of the waves that were there before. And now this is interesting because when you add the observer, it changes the outcome. So it doesn't make it choose a wave sort of action, it makes it choose a particle-based action. So this changes the behavior of light. Now, as shown in this photo, you have your detectors, and you can see on the left, when you have classical mechanics and you have a detector, you get two bright lines. Quite simple. When you take away the detector, you have fringe patterns, just like waves. Now, the key to all of this is something called superposition. This is the ability of a quantum object to be in many different states at the same time. In this case, being in a wave and a particle state at the same time. A thought experiment was done by Schrödinger with his cat. Basically what he said was, if you put a cat in a chamber, and there's a 50-50% chance that the poison gas in that chamber will kill the cat, or it will not. The only way you can determine whether the outcome is a cat being dead or the cat being alive is by opening up the chamber and actually observing, in the same way that the observer saw the particles. So, if you never observe, the cat is both dead and alive simultaneously until you observe, forcing one of the outcomes. This was important in superposition because he made the wave function, and he said when you observe the particles, you collapse the wave function, basically making nature choose an outcome. And in this case, when you don't have any observer, it doesn't choose any outcome, it acts as a wave. But when you do have an observer, it collapses the wave function and it acts more classically, like if you're shooting golf balls through the slit. Now, this is just a brief introduction to quantum theory. I hope you enjoyed this lesson and I hope you learned something new.